Welcome back. Following on from my air, I'd started last lesson video 37 minutes or so. It was getting a bit long, and therefore I've tagged this as a separate video to go on with that, like part two, air part two, if you like. And our syllabus demands that we know about thermal decomposition. Now, decomposition is breaking down. Decomposition is breaking down of a chemical into fragments, and thermal decomposition, thermal decomposition. Thermal decomposition is about using heat to break it down. You may have come across with oxygen, making oxygen. It was catalytic decomposition. A catalyst broke down hydrogen peroxide. Well, here, these carbonates we're going to discuss, we're going to heat them with a roaring flame of a Bunsen. The Bunsen burner roaring flame is what will break them down. Now, if we heat up marble, then you get calcium carbonate chemical within the marble will break up or decompose as follows. Look, marble is white. When you heat it, it will turn to calcium oxide, which is white, and carbon dioxide. Now, if you watch my video, the practical video, where I've done this with carbonates, I use a lime burner. Marble chips, or marble calcium carbonate, generally has a common name. People call it lime. And lime, if you heat it really strongly, heat lime, then it glows. And I've done that in a video. And that's why the phrase that glow is used for, like that phrase, like standing in the limelight. The problem with decomposing lime or marble is the white solid you start with turns to a white solid you end up with. So it's not visually stunning, but it is, because when that happens, it gives out light. So it's very bright while it's going. While you're heating it, very, very bright. But it's not a change of colour. Examinations very often ask this next one, which is very visual and is a change of colour. Now, copper carbonate. Certain chemicals you need to know the colour of. Copper carbonate is one of them. Copper carbonate is green solid. If you take a green solid, green powder, take the green powder and heat it, it turns to a black powder. See, green turning black, very visual. No mistaking that. And when it does, you get this powder bubbles. The green powder bubbles and it turns black. So it's going black because that's being made. Why is it bubbling? It's bubbling because of carbon dioxide gas is coming off. So carbon dioxide gas comes off, it bubbles. The two observations, that's like visually what you see, the two observations are effervescence, that's bubbling or fizzing, and the other is colour change from green to black. So you need, as a good chemist, to know what the important observations are. And when you're starting on this journey of chemistry, I would just learn what the important observations are from your teachers. And I would say they're the two important observations with copper carbonate. Another important carbonate is baking soda. Now, baking soda is sodium hydrogen carbonate. It's a type of carbonate. It's got an extra hydrogen in it. It's not just sodium carbonate, but sodium hydrogen carbonate is baking soda. And when you heat that up, then it decomposes. The heat will break it down into sodium carbonate and water and carbon dioxide. And this happens not in the cold. You need heat. So cold baking soda stays as a white solid. Take a little bit out, mix it with some dough like chapati flour, mix it with some chapati flour and bake it in an oven. In the oven, when the oven gets hot, I think at A level I will calculate an exact temperature at which the bubbles of carbon dioxide will be given off. But at a certain temperature, when the oven is hot enough, carbon dioxide gas is liberated. Carbon dioxide gas comes off from the sodium hydrogen carbonate. As the sodium hydrogen carbonate decomposes, one of the fragments, one of the pieces, is carbon dioxide gas. And that gas is what makes your bread rise. It's what turns like your dough into naan bread, which is like got bubbles inside it. Personally, I prefer chapatis. And chapatis don't put any of this rising agent. Chapatis are unleavened bread. It does not rise, it's just flat. I like that flat, non-rising. But, if you're into your cakes and your bread, you want your bread to rise. You want your cakes to rise. You want them to have holes in so that they are moist and soft and the texture is right, etc. So baking people use sodium hydrogen carbonate, and that to me is a classic example of chemistry in action, where the carbonate, when it's heated, breaks up to give you the bubbles that you need for the cakes or bread that you're trying to make. Now, if you look at my video, I do have a video where I heat all of these three things. I heat the lime or the marble chips using a lime burner. I heat the green copper carbonate, turning it black, and watch the fizzing. And I heat the sodium hydrogen carbonate and I bubble the gases through lime water and prove that carbon dioxide gas is coming off from that reaction there. So watch the video to get your mind around decomposition of carbonates and learn the few colours. I know it might seem a bit random, me telling you to learn colours of random chemicals, but it's not. The chemicals I tell you to learn are the chemicals that come up in exam papers. So they're not random, even though you might think so. You need to learn the colours. Copper carbonate is green. Copper oxide is black, that you should know already. Copper itself is a red-brown or a red-orange solid. And in air, when you heat it, it turns black. The blackness is copper oxide. Certain colours, certain chemicals you've got to know. And as we do more and more chemistry, I will tell you which are the important ones. But a lot of them are white solids and a lot of the gases are colourless. But the ones that are not white and the gases that are not colourless, they are the gases you need to learn. And they're the gases that exam boards ask about. So learn them. Okay, that's it. I'll stop the video there. All the best.